Welcome back, everyone. This is 8.4a, the law of cosines. Remember that this video has the A here, so this is just for Algebra 2, not for honors. Now, your learning goal in this one is to use law of cosines, which is how we can use cosines when we have a triangle that's not a right triangle to find sides or angles. Okay, so we're going to segue into law of cosines. Okay, now the previous portion was law of sines, and that solved a very specific situation where maybe we're looking for a side, or maybe we're looking for a specific angle, and we have 3 out of 4 pieces of information we have. Well, there's going to be some situations where the law of sines is just simply not going to work, and we're going to need the law of cosines. And we have 3 formulas for the law of cosines, okay? And each one is set up to solve for, either A here, or we can also undo it and solve for these angles, okay? Either one is gonna be fine to use it as, all right? But we still need a lot of information. We need at least the other sides, okay? So, these look confusing. It looks hard to memorize them. After we draw a triangle, we use one. I'm going to come back to it and help you kind of, come up with some strategies to remember what this looks like. So let's just draw one on here and do it, okay? So we got a triangle. It's a non-right triangle, just like with law of sines. We're going to have A, C, and B. And we're going to be given the little a is 8, the side B is 11, and the angle for C is 37 degrees, okay? Now, what are we trying to find? We're going to try and find length AB right here, okay? Now, if you look, we have to first decide which one of these are we going to be using. Well, length AB, that's also just what we call little c, because it corresponds this, right? So we're going to need to use the one that's basically already solved for c, except for we'll have to take the square root at the end. Now, if you look, we have little a, we have little b, which we're going to use twice, and we have angle c. So we actually have all of the pieces of information we need for this one, okay? So that's kind of help. Now, how do you remember these, right? If you look, there's kind of a pattern. Look, at the side you're solving for is also the angle you're taking the cosine of, okay? The side you're solving for is also the angle. The side you're solving for is also the same letter angle, right? The other 2 sides appear twice. You square them both, and sum them. And then you subtract in all of them by 2 times the sides times the angle, okay? So think about this for a second. The side you're solving for is the angle you use. The sides you're not solving for, you square and sum, subtracted by 2 times both those sides. See this? See them pop up? Now, if that confuses you still, you'll just want to refer to this, okay? So let's set this one up, okay? We don't know what c is, but we have c squared is equal to a squared, which is 8 squared, plus b squared, which is 11 squared. And if you really think about it, that order doesn't really matter. So if you weren't given complete information on which side was A and which side was B, if any of these can't be negative because they're triangle, you can do these in either order. So it's not really that important which one's A and which one's B. Minus 2 times 8 times 11 times the cosine of 37 degrees, okay? Now, this looks complicated, but if you bring it back here, this is all work that can easily be put into a calculator, right? And then once you do all this, you take the square root of it, and you're gonna get what c is equal to. So let's get our calculator up, all right? And let's get this going. So we're gonna do 8 squared plus 11 squared, okay, minus, and I'm going to put all this in parentheses, 2 times 8 times 11 times, I'm just going to click in because sometimes it seems to give me errors, cosine of 37 degrees, okay? Now I know we need to take the square root of that, but I'm going to get a number, that's 44. And now I'm going to take, where's my square root on this crazy calculator? There it is, of the answer, all right? and I'm going to get 6.66634. So that side is 6.6. We'll round to the next place, 6.67 approximately. Okay. Now, if you look at this, that makes sense, right? Think about this. If this angle is 37 degrees, right, these angles pretty much have to be bigger than 37 degrees, right? In order for this to add up to 180. And this side is 11, this side is 8. So this side should have the biggest angle. This should have the next biggest. And this having the smallest angle should have the smallest side at 6.67. Okay? So, it was a lot there, right? And I understand that, okay? Law of cosines works in this specific situation because notice this. We only have one angle, right? And we're looking for a side. If I tried to do this with law of sines and I'm solving for the same side, I have a missing here. And if I try to use another side, I have another missing because I don't know what angle B is. Or if I try to use A, I don't have angle A. So there's going to be very clear situations when you can use law of sines and when you can use law of cosines. If you find yourself picking one and you have too many unknowns, maybe you need to switch to the other one, okay? Now, I do have another one for you guys to use. I want you guys to try this first. We are going to be looking for the angle this time, though. So we're going to be finding the angle A, and our triangle, let me get rid of that calculator since I'm so good at leaving that in there. Our triangle is going to look like this. Hold on. We're going to have A, B, and C. We're going to have 9, 8, and 5. And we're looking for this angle A here. Okay? So, before you get started on it, think about which one of these you're going to need, right? In fact, I'll help you out with that part. You're going to need this one because you're looking for angle A. Okay? So, why don't you guys pause it and give it a try. It's okay if this one's a little bit tougher to do, but I think you guys can handle it. Okay, so first thing we do is we set up our formula, right? We have that's my highlighter. A squared is equal to B squared plus C squared minus 2BC times the cosine of A, like that. And I'm going to plug in the information that I have, okay? So I have 8 squared is equal to 5 squared plus C, which is 9 squared, minus 2 times B, which is 5, times C, which is 9, times the cosine of A. Okay? Now, in order to solve for the cosine of A, I need to get that by itself. Okay? So we could do a lot of this work, with the calculator here, or we could do it by hand. It might be a little bit better to start doing things by hand because we have to split things up the right way. This is 64. This is 25. This is 81. And we're going to multiply these together. So 2 times 5 is 10. 10 times 9 is 90. So that becomes minus 90 times the cosine of A. Okay, so I'm going to subtract over my numbers. So maybe I should just add those together. 25 plus 81, we get what, 86, 106? Yep, 106. And I'm going to minus that to both sides. Okay, so all this cancels here. 64 minus 106 gives me what? 42, negative 42? So negative 42 is equal to negative 90 times the cosine of A. Okay, I'm going to divide by negative 90. That's going to cancel. And I'm just going to leave this as 42 over 90 for now is equal to cosine of A. In order to do this next part, we have to take the inverse cosine of each side. So that cancels. I'm going to have the angle A is equal to the inverse cosine of 42 over 90. Now, I know we could have simplified that, 42 over 90, but because we're going to have the opportunity to just use the calculator, why simplify, right? So I'm going to bring that calculator back, okay? We're going to use the inverse cosine of 42 divided by 90, and we get 62. So the angle A is equal to, we're going to round this to the hundreds here. We get 62.18 degrees, okay? So that was this angle. A little bit harder to verify, when we don't have all the angles, but I mean, it kind of makes sense, right? This should be our middle value, and 62 is a good middle value to have, okay? So that, means that this one should be a little bit bigger. This one should be a little, a lot smaller, all right? Okay, so a little math talk here, right? Law of cosines, law of sines. There's a lot going on with it, okay? We use these for triangles that are not right triangles, okay? In class, I would have shown you a little bit about how trig is not going away. It's going to be super important to solve the difficult problems that we need solved today, okay? And of course, my calculator's still up, all right? All right, that's all I got for you guys. Good luck. Hopefully you got it. I'll see you next time.